Let's take a look at the following three geometric series and see how they behave. In the first example, we have a common ratio of 2, and you can see that the terms are growing exponentially. Now in the second series, we have a common ratio of half, and we can see the opposite effect happening. The terms decrease exponentially and eventually approach 0. In the third series, we have something really similar to the second series. You can see that we basically have the same terms, but this time the signs alternate. And this is because the common ratio is now negative half instead of positive half. Because the terms in the second series and third series eventually approach 0, we can add an infinite number of these terms and still get a value. This is called the limiting sum, and we briefly saw this in action in the last video. The formula for calculating the limiting sum is given by S infinity is equal to A divided by 1 minus R, where the absolute value of R is less than 1. This means that R can be positive or negative as long as the absolute value or magnitude of R is less than 1. Now let's try to work out the limiting sum of the second and third series. For the first series, S infinity is equal to A, which is 128, divided by 1 minus R, which is half, and this gives us 256. So that means if we added an infinite number of terms in this series, they would still just add up to 256. And I think that's super fascinating, but not unexpected. Now for the second series, S infinity is equal to 128 divided by 1 minus negative half. And this comes out to 83.33 repeater. You can see that this value is less than the limiting sum of the second series. And that makes sense since some of the terms are negative and will bring down the overall sum.